Today we're going to be working on making sure that you understand how to find number of protons, neutrons, and electrons in any type of atom that you're given. So you will need your protons, neutrons, and electrons practice worksheet, and you will need a copy of the periodic table. So if you don't have those things right in front of you, pause the video, go find those two things, and then come back, and then we'll continue. So initially what you're going to see on this first line here is that you have a B with an 11 up at the top, and you will remember that the symbol is usually the first two letters of the element's name, either in English or in Latin, and this number up here represents the mass number of this particular atom. Okay, so how am I going to fill in the rest of this? Well, this number that's up here is always the same as the mass number. So I can take the number that's up here in the symbol and I can go in and fill that number in over here, because that is the total number of protons plus the neutrons together. They'll weigh 11 AMUs together. But how do I find the rest of this? Well, that's where the periodic table comes in. You need to find the symbol for boron. And if you look at your periodic table, you will find that it happens right here. There's a B. The atomic number, you'll notice that we talked about before, is the whole number. They go from 1, 2, 3, 4, 5, 6, 7, 8, 9. They're the whole numbers. They're not decimal numbers, the whole numbers, and they just gradually increase as you go from left to right and as you go down the table. So if you find boron, you'll notice that there is a 5 in the box with that one. So the 5 is the atomic number, and if you know the atomic number, you automatically know the number of protons in the nucleus, and you automatically know the number of electrons that are surrounding it. The reason that you know both of them is because an atom has equal numbers of protons and electrons so that the charge will be balanced, and the number of neutrons then becomes the part that you have to figure out. Well, remember that we said the electrons have very, very little mass, and so the mass of the atom comes from the protons and the neutrons together. If I know that the atomic mass is 11, and I know that the number of protons is 5, what that tells me then is that if I subtract these two, 11 minus 5, then the number of protons is going to be 6. Now, you may notice on the periodic table that the table says that the mass of boron isn't 11, it says that it's 10.811. It's a decimal number. Well, where did that come from? What I'm going to show you is not something that you have to remember or necessarily even understand, but if you're curious about it, I want you to understand at least where it comes from. Let's say that I have 4 boron 11 atoms. So each one of these is going to have 5 protons and 6 neutrons in the nucleus. And then let's further say that maybe I also have a boron atom that's boron 10, and it's going to have 5 protons again, because remember, the number of protons is like the fingerprint of the atom. Every boron atom is going to have 5 protons. That's an absolute rule that isn't ever going to change. So this will also have 5 protons, but this one will only have 5 neutrons in the nucleus, because the mass number is 1 less. So if I wanted to average together the mass of these, I would imagine all of you already know how to find an average. So if I would take 11 plus 11 plus 11 plus 11 plus 10, because those are my 5 masses, if you add those up and you divide by 5, you're going to end up with 10.8. And so that's really what the atomic mass on the periodic table is. They've taken all the isotopes of an atom that exist, and they average them together, and they say, well, the average mass of all the boron, of each boron, would be 10.8. So the number on the periodic table is the average, and it will tell you what the most common isotope is. And so because it's 10.8, that rounds to 11, so I know that for boron, this is the most common isotope. You notice here I had more 11s than I did anything else, because the number's close to 11 if I would round it. So this is a very specific atom, whereas the mass that you're given on the periodic table is an average of all of the atoms that exist for that particular element. Okay, let's look at the second line. Here, I don't have the symbol this time, but I'm told that the atomic number is 11. So if you look at your periodic table, you just need to follow your whole numbers down until you get to an 11. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so you should see that element number 11, or the atomic number 11, is a sodium atom. And the symbol for that is Na. Okay? Now, in this one, we've been given the atomic mass. It's 24. So the 24 goes up here as a superscript on this side. And once again, if I know the atomic number is 11, I automatically know that the number of protons is 11 and the number of electrons is 11. So therefore, because protons and electrons have to balance each other out, I know that they're always going to be the same. The mass is 24, so subtracting the mass from the protons will give me the number of neutrons, and so 24 minus 11 is going to give me 13. Okay? Is this the most common isotope? Well, if you look at the periodic table, it says that the mass of a sodium atom, again, if you read it off the periodic table, you'll see that it's 22.99. So this one is not the most common isotope. The most common isotope is a sodium 23 atom because that's what the mass reads off the periodic table. So that's the most common isotope of sodium. Look at magnesium, which was right next to it. What would the most common isotope of magnesium be? Well, the number on there is 24.305. So the most common isotope of magnesium is a magnesium 24 atom. Do one more. Go right below the sodium and the magnesium to potassium, which it has a symbol of a K. The K says 39.098, and so therefore the most common isotope of potassium is a potassium 39 atom. Okay, because you're going to round whatever number is on there, and that's going to give you the most common isotope. These won't necessarily be most common, but it's just the particular isotope that we're working with. Okay, let's go on to the next example. Here, I've been given the number of protons and the number of neutrons. Well, if you remember, the number of protons is the same as the number of electrons, because it has to be electrically balanced. The number of protons and the atomic number are always the same. So now I need to go to the periodic table, and I need to find element number 31. So if you look, you should find 31 about right here on the periodic table. You should see that it has a symbol of Ga for gallium. Okay? What number goes up here? Well, they didn't give me the mass number this time, but the mass is whatever the protons and the neutrons are added together. So if I add 31 and 37, I get 68. And so 68 is the number that goes up here on the top. All right. Next example down. I have 50 neutrons and 39 electrons. Okay, well, if I have 39 electrons, I must have 39 protons as well, because the charges have to balance, because I need a total charge of 0. If the protons is 39, then that means the atomic number must be 39. And so you're going to have to find 39 on the periodic table now. And you will find 39, the fifth row down, it's going to be right here. It has a capital Y, yttrium. And again, I don't have the atomic mass given, but I can figure it out because the mass is the number of protons plus the number of neutrons. So 39 plus 50 is going to be an 89. So I'm going to have an 89 there for that particular isotope. Is that the most common isotope of yttrium? If you look at it, the atomic mass on the table says 88.9, which rounds to 89. So in this case, this is the most common isotope because that's If I round the number on the periodic table, that's what I will get. We'll do one more example together. Now I've been given 29 protons and an atomic mass of 64. 29 protons means I have to have 29 electrons. It means the atomic number is 29. So again, you're going to need to look for atomic number of 29. So here you've got 19, 20, 21, 22. You keep going across and you'll get to 29 about right here on the periodic table. And that element is Cu, which is copper. I know that the atomic mass is 64 because I was already given that. So the 64 goes up here. And how many neutrons will I have? Well, remember, protons plus neutrons gives me the atomic mass. And so there, if I take 64 minus 29, I'm going to have a number of neutrons of 35. There is one thing that I want to point out to you as you get higher and higher atomic numbers on the periodic table, which you probably are going to find before you get to the end of this worksheet. When you get down to, and I'm actually going to show you on the periodic table in your textbook, because it's a little easier to see because it's color-coded. When you get to this point right here, you actually have to kind of skip down to this row that's underneath the periodic table. And this one right here, you have to skip down to the bottom row on the periodic table. Now, why did they do that? Well, because if they were actually going to stick these where they would go, the periodic table would be really, really, really long and cumbersome to try and print it. So that's the only reason that they moved it. So you can see that barium is element number 56, and then element number 57 is down here at the bottom, 58, 59, 60, all the way up through element number 71, which is over here. And then you're going to go back up to element 72, which is over here. And then the same thing is going to be true on this bottom row as well. So if on this worksheet, if you have numbers that are higher than a 71 for the atomic number, you may be aware that you may have to look down here to find those. So what I recommend that you do, we've done about half of this worksheet together. What I would like for you to do is to finish the rest of that worksheet. I sent you the answers to it, so finish the worksheet, check your answers, make sure that you understand it and that you're doing them correctly before you attempt to do the rest of your homework assignment, okay? And as always, if you have any problems, make sure you let me know.